Hello everyone, welcome back to Tales of Chemistry. We are continuing with organic compounds containing nitrogen. Today's topic is all about aniline. All about aniline as in the method of preparation. How is aniline prepared? What are the physical properties? What are the chemical properties of aniline? This is what our topic today. Let us begin with the lab method of preparation of aniline by reduction of nitrobenzene. What is nitrobenzene? Benzene ring with NO2. This is nitrobenzene, and for reduction, we need to use nascent hydrogen. Now, what will provide us with nascent hydrogen? You can use any reducing agent. Let me choose tin in HCl, metal tin in HCl at around 333 Kelvin. It's fine if you cannot remember the temperature, just a delta will be enough. Just show that it is heated. Nitrobenzene is heated in presence of tin in HCl. Now, the product that you get here are, one is NH2 on the benzene ring, which is nothing but aniline, aminobenzene, aniline, right? And the oxygens which you have removed from NO2, those oxygens will combine with hydrogen to give you two molecules of water. Now, this is very similar to the reaction that we have studied in the beginning of organic compounds containing nitrogen, that is in part 1. Any nitro compound on reduction gives you the corresponding amino compound. So, primary amines are prepared by this method. Next is the industrial method of preparation, large scale method of preparation from chlorobenzene. Now, I have missed the gap between from and chloro. Please ignore that. Now, chlorobenzene, that is benzene ring with a chloro group. This is chlorobenzene. That has to be, chlorobenzene has to be treated with ammonia. Ammonia in presence of cuprous oxide, Cu2O, cuprous oxide at a high temperature, 473 Kelvin and 60 atmospheres of pressure. Again, if possible, remember the temperature. Otherwise, just write high temperature and pressure. Just put the delta and pressure. All right. Now, the product that you get is Cl group is replaced. Where is the Cl? Here. This Cl is replaced by NH2 group. From where am I getting NH2? I have taken ammonia. NH3 is there with me. So Cl is replaced by NH2. And then the Cl atoms which you have removed, that will be combining with copper to give us cuprous chloride, CuCl. Alternatively, you can write 2CuCl as CuCl2 also. Both mean the same. Plus water molecule. So this is the completely balanced equation, and make sure that you are writing all the byproducts as well as you are making sure that the balancing is done properly. So let's repeat this. This is an industrial method of preparation, large scale method of preparation, starting with chlorobenzene. Chlorobenzene is heated with ammonia, aqueous ammonia actually. Okay, heated with ammonia in presence of cuprous oxide At 473 Kelvin temperature, 60 atmospheres of pressure gives us aniline, cuprous chloride, and water. So these are the only two methods of preparation exclusively for aniline. Now, regarding physical properties, there is nothing much to memorize under the physical properties of aniline. So first of all, it is a oily liquid. Oily liquid. You will have to do organic analysis with aniline, so you will get to see how aniline looks like. It's an oily liquid. It has a characteristic smell, and it is very slightly soluble in water. Very slightly soluble in water. So just one or two physical properties, if you can memorize, that will be good. Now, chemical properties of aniline are very important. Under the chemical properties of aniline, the most important one is its reaction with HNO2. HNO2 is nitrous acid. Nitrous acid. Now, one drawback with this nitrous acid is you cannot prepare and store it. So you need to prepare it when you need it. Therefore, let's take aniline. I need to treat aniline with HNO2. Now, since HNO2 cannot be prepared and stored, what I'm doing is I'll prepare HNO2 by the reaction between NaNO2 and HCl, sodium nitrite in dilute hydrochloric acid. These two will react together to give us HNO2. Another very important point here is the temperature, 0 to 5 degrees Celsius. If you are not writing the temperature, you won't be getting any marks for this equation. Temperature is very important here. Now, aniline is converted to benzene diazonium chloride, N2 plus and Cl minus. It's converted to benzene diazonium chloride. Along with this, you are getting 2 molecules of water. Now, if the same reaction is conducted, imagine you're performing the same, okay, that you took aniline, you treated it with HNO2, same way by mixing NaNO2 and HCl. Only difference is you are performing this at a room temperature, or precisely speaking, any temperature above 5 degrees Celsius. Yeah, above 5 degrees Celsius, if you are, performing the reaction between aniline and HNO2, that is NaNO2 and HCl, you will be getting corresponding alcohol. That is here, phenol will be the product. Phenol plus N2 plus H2O. Phenol plus N2 plus H2O. All right. So this is the reaction. Notice the change. Only temperature is the difference. If you want diazonium chloride, you need to keep the temperature between 0 to 5 degrees. If you need a phenol, then the temperature has to be a room temperature or above 5 degrees Celsius of temperature. Okay, so this is kind of a frequently asked question, reaction of aniline with the HNO2. Okay, so keep this reaction in mind, write and practice. let us move on with the next reaction of aniline, that is alkylation. We have done alkylation several times with other amines. So let us repeat that with aniline now. This is aniline. Aniline is treated with, it is alkylation. So I need to have an alkyl group. Alkyl chloride is taken. CH3Cl is taken. One of the hydrogens from aniline and this Cl is removed as HCl. So what I have now is the benzene ring. NH is remaining. There are two hydrogens on nitrogen, of which I removed one along with chlorine. There is one more which is remaining, isn't it? So that is this NH. Onto that position, this CH3 will be migrating to the nitrogen. So you have your CH3 here. Okay, along with HCl. Now, how do we name this product? The parent here is aniline. In aniline, on nitrogen, you have a methyl group. So this happens to be N-methyl. Yeah, N-methyl. And then write the parent's name, that is aniline. N-methyl aniline. Now, similarly, you can continue the reaction. You can continue the reaction taking N-methyl aniline. Because one more hydrogen we are having, right? So repeat the reaction with CH3Cl. Again, one more alkylation. The second hydrogen is removed along with Cl. So one of my products will be HCl. And I will get benzene ring, nitrogen, and on nitrogen, there are two CH3 groups. Again, aniline is the parent. On nitrogen of aniline, we have two methyl groups. On nitrogen of aniline, there are two methyl groups. So this is N, N dimethyl, N, dimethyl aniline, N, dimethyl aniline. All right. So that is alkylation of aniline. Now, the next reaction is acetylation. So here again, we have studied this reaction also earlier, but we are repeating it using aniline. So this is aniline. For acetylation, we need to take acetyl chloride. What is acetyl chloride? CH3, C double bond O, Cl, acetyl chloride, and use pyridine, the base. Okay, now H and Cl, as told earlier, from aniline, remove the hydrogen, and Cl from acetyl chloride, you get HCl, and there remains your benzene ring, N with one hydrogen, the other hydrogen is removed, and now you have C double bond O, CH3 in it. Now, this particular compound has a name, acetanilide. You have to put in effort and remember this name, acetanilide. Okay, so that is an example for acetylation. Similarly, all these reactions are very much similar to each other. Benzoylation. Now, in benzoylation, what is that we are taking? Benzoyl chloride. So this is aniline and treat it with Cl, CO, C6 H5. You can write C6H5 or you can draw the ring as well. No problem, no difference. Now, H and Cl is removed as HCl. I hope you understand. H is taken from NH2. One hydrogen from NH2 and a Cl from benzoyl chloride. Okay, there is only one Cl. So that Cl from benzoyl chloride is removed. Now, what we have is the ring with a hydrogen on it, and this is connected to C double bond O, C6H5. Let me draw a ring here. Just that you will understand, instead of C6H5, you can even draw the ring. Benzanilide. Benzanilide. All right. The name is benzanilide. Now, the next reaction which we are going to learn is carbyl amine reaction. Very important reaction of every primary amine. But here we are just talking about aniline. Previously, we have studied that every primary amine will undergo this reaction. This is a test for primary amines as well, because only primary amines undergo this reaction and they produce a disagreeable smell. A foul smell is generated. So if you perform such a reaction and you get a foul smelling compound, you can conclude that the amine that you have taken is a primary amine. So here we need to treat aniline with CHCl3 chloroform with the potassium hydroxide dissolved in alcohol and just slightly heat it or warm it. You don't have to heat it to a high temperature. Just heat it slightly. You will be getting your benzene ring on that NC. This is an isocyanide. Isocyanide. So here it is phenyl isocyanide. Along with phenyl isocyanide, you will get KCl and water. KCl and water. So that is carbyl amine reaction, exclusive reaction of all primary amines. Every isocyanide will have a terrible or a foul smell. So that is the method to identify them. Now, the last set of reaction that we have under aniline is electrophilic substitution reaction. The next topic that we need to study is electrophilic substitution reaction. Now, electrophilic substitution meaning something positively charged is replaced by another group which has a positive charge. Now, so first of all, let us see the bromination of aniline. So this is aniline and I am treating it with bromine water. So I'm writing 3Br2 aqueous. It is compulsory to write either bromine water or AQ. Also, balancing is always compulsory. Now, you will be getting a product with the benzene ring and all the three positions, both the ortho and the para position, all three positions are simultaneously substituted by Br group. Now, this is called 2,4,6 tribromo aniline, 2,4,6 tribromo aniline, which is a white precipitate, 3 HBr. Okay, so all these positions, we actually have hydrogen. We are removing those hydrogens and giving back Br plus. H plus is removed, Br plus is given back. So HBr is the byproduct. Name of the major product is 2,4,6 tribromo aniline, which is a white precipitate. 2,4,6 tribromo aniline, which is a white precipitate. Now, if at all you need either ortho or para or a mixture of ortho and para bromo aniline, then the NH2 group has to be protected. So, once again, we are learning bromination, but in a different way. Take aniline, treat it with CH3COCl in presence of a base. You're very familiar with this reaction. This is acetylation, and as a result of acetylation, you will be getting benzene ring, NH and C double bond O, CH3. So this is something which we have studied. We know that this is acetanilide. Once you get acetanilide, treat this compound with bromine. Now, benzene ring, this NH part will remain intact. No change will happen to this. You will get a mixture of orthobromo acetanilide, as well as you will get parabromo acetanilide. So this is acetanilide. Now parabromo acetanilide. You are getting a mixture of orthobromo acetanilide and parabromo acetanilide. Now treat this. Okay, treat this acetanilide with acidified water. So in other words, subject this to acid hydrolysis. Subject this to acid hydrolysis. So what happens is this bond will break. Both cases, this NH and CO bond is breaking. And from water, what is water actually? H and OH, right? H of water will be approaching nitrogen and OH of water will be approaching carbon, because of which you will be getting, see, N and H. This was already there, and the NCO bond, you broke it. Over there, H will go. Which hydrogen? Hydrogen from water. Okay, and CH3CO with a broken bond here. OH of water will be migrating to that. So you are getting acetic acid. Sorry, here I missed out this bromo. Now, with ortho also the same reaction can be conducted. I have just taken para as an example. That is it. Either ortho you can take or para you can take and complete the reaction. So now look at both the reactions. If you are using bromine water, you are getting a tribromo derivative. Instead, if you are protecting the amino group, you're protecting the amino group and then conducting the reaction, what you are getting here will be a mixture of orthobromo aniline as well as parabromo aniline. Now, the next reaction which we need to study regarding aniline is its nitration. But bromination is a very repeated question. Completely study bromination. Nitration, surprisingly here, we get three products, as in ortho, meta, as well as para. Take aniline, treat it with concentrated HNO3 in presence of concentrated H2SO4. So HNO3, nitric acid and sulfuric acid mixture, nitrating mixture, right? We are getting NH2 here with ortho product, plus we will get a good amount of meta, not traces, good amount of meta product. We are also getting a good amount of the para product. So orthonitro, metanitro, paranitro, aniline are obtained. Now, one question that arises here is, why is the meta product? Right. We can understand that aniline is ortho-para orienting, or it is ortho-para directing group. Then, if it is ortho-para directing, why do we get meta product? That too, a good amount of meta, around 47% is meta product. Yeah, ortho is just 2%, 47% is meta. Why are we getting so much of the meta product even when aniline is ortho-para orienting? So here what has happened is HNO3 H2SO4 mixture is a strongly that provides a very strong acidic medium. In this acid medium, your aniline converts to anilinium ion. So, point number one, keyword number one is the medium is acidic. Then aniline gets converted to anilinium ion. Aniline gets protonated and you get anilinium ion. NH3 plus NH2 will become, NH2 becomes NH3 plus. So this change happens in a strongly acid medium, and this particular group is meta-directing. So it's not aniline which is meta-directing, but it is the anilinium ion which is meta-directing. Now, as done in the case of bromination, here also you can protect the NH2 group. Thus, you can prepare a mixture of orthonitro-aniline and paranitro-aniline. You can avoid the meta product by protecting the NH2 group. So this is nitration in a different way. Nitration by protecting the NH2 group. Let's see how is that done. So this is your benzene ring, this is your aniline. Treat it with acetyl chloride. So this process is acetylation. We need a base, pyridine, for acetylation. Now, acetylated product, that is acetanilide, you are familiar with it. NH, C double bond O, CH3, protecting the NH2 group is done. Now, treat your acetanilide with your nitrating mixture. Concentrated HNO3, concentrated H2SO4. Treat it with the nitrating mixture. What you get is here, this remains intact, NH, C double bond O, CH3. This remains intact. And NO2 on the ortho 1 plus one more possibility, NHCO CH3 with NO2 on the para position. So you are now getting orthonitro-acetanilide plus para-nitro-acetanilide. Now we need to get rid of that acetanilide part. So we will hydrolyze it. How do we hydrolyze? In presence of acid. Acid hydrolysis. As told earlier, the N and CO bond will be breaking. From water, H goes to nitrogen, OH goes to the carbon. Both cases, H and OH goes to the carbon. Now, what you will get after hydrolysis is, this will become NH2 and you will have NO2 here. I'm skipping that ortho product. I'm writing only the para one. Plus, along with that, CH3, C double bond OH, which is acetic acid. That is about nitration. So, bromination is of two types. Nitration is also of two types. Last electrophilic substitution reaction is sulfonation. Now, let me write this in the easiest way for you so that you will remember it easily. Skipping certain intermediate steps, I'm writing this. Aniline treated with sulfuric acid, definitely concentrated sulfuric acid. You don't need any protection, yeah? And what you get here is NH2 and SO3H. This is called sulfanilic acid. Sulfanilic acid will be the product. Okay, so in sulfanilic acid, if possible, remember this, there is a proton exchange which is possible. The H from SO3H can shift to nitrogen and this can become NH3 plus, and here this is SO3 with a minus charge. So this is an internal salt. Within the same compound, there is a positive terminal and a negative terminal. Such internal salts are called Zwitter ion. So you are getting a Zwitter ion here. Now, definitely till sulfanilic acid you need to study. The rest is your choice. Yeah, there is automatically, without you doing anything, this H of SO3H will be shifting to NH2, and that is a Zwitter ion. Zwitter ion is not the name of this particular compound. Zwitter ion is a general term for all such internal salts. All right, that's all about preparation and properties of aniline. In the next video, we will continue with diazonium chlorides. Please stay tuned. Thank you.